Hi guys, and welcome to Learn Extra Live. It is a Tuesday, that means it is physical science, and as you can see, Phil is standing next to me and it's grade 10s. I have done a shout out, said who's joining us, and I see that Lesego is in. So Phil, tell us, what are we talking about today?
Okay, well, today we're picking up where we left off last week. We started talking about vectors and scalars, and a lot of people were writing in with some really good questions, and we're going to pick up where we left off last week, and we're going to do some displacement, and we're going to compare it with distance.
Okay, awesome. And apparently Phil's told me you need rulers, you need protractors, you need your pens and pencils, and you need to get ready for an awesome show.
Absolutely, I'm going to do just that.
Awesome. Take your little spot. Okay, guys, so you guys know the drill. What you need to do is you need to join us on facebook.com/Learn Extra, or you can chat to us on Twitter @Learn Extra. And as usual, we are giving away a Casio calculator to the best post on the page. And what this can be, guys, either you're helping each other out on the page, maybe you're posting questions, maybe inspirational tips, chips. Obviously, I'm hungry. So don't forget that this community, guys, is for you. It's not just for us. It's for you to start chatting, to learn more, and to learn extra. And a big shout out to Liberty. Thank you guys for making the show possible. You guys rock. Let's get chatting and let's start the show. Phil, take it away.
Thanks so much, Indy. Okay, well, as Indy says, this is an interactive show. You guys are going to be doing some of the work with us. You can't just do this stuff by watching us. I want you to write down everything we say, and what I'm going to be doing is, I know that the grade 12s are quite used to this, is I pose a challenge question. Now, I'm going to ask Indy to pose up that challenge question on the Facebook page. I want you guys to get some pen and paper and start working with that. You're going to need some pens, pencils, some protractors to work through this. Okay, so most of you have guessed that today's topic is displacement and distance. Now, a lot of people have got misconceptions about this. You were kind of confused from last week what the difference between a vector and a scalar was. Now, we're going to try and dispel some of those problems that people have got between displacement and distance. But before we do that, we're going to give you a chance to start working, to start chatting on the page. We're going to post up that challenge question, and here it is. It's quite a busy one. Well, we're almost there. Hang on. There we go. All right, our challenge question for today is up. Okay, now this is a map. Now, I'm going to help you through this map. It looks like a lot of information. It's very difficult to draw down, so I want you to get on the Facebook page and actually take a look there and see if you can't figure it out. Okay, so now I'm looking for the displacement. Let's highlight some of the important information that we've got in this challenge question. I've asked you for the displacement. Remember from last week, there is a difference between distance and displacement. Okay, now I want the displacement moved during a journey. Now, the problem is that I've actually given you an overhead map. Now, this is going inside the challenge question, and I've given you some blocks. Now, these blocks have got measurements. Those measurements are 100 meters by 100 meters. So I hope that you can see that on your screens. I'm pretty sure my producer's got it up on the screen. Each one of these blocks is 100 meters by 100 meters. I've given you a starting point and an end point. Now, you've got to navigate from the start to the end and find me the amount of displacement which has happened during this. I've also given you some other important bits of information, is that there are roads and there are blocks, and you may only travel on the roads. Other important information to note is that I've got a north reference. I'm told that this is a map, and usually maps, you get a north reference on your map, and there it is. So now I've got to find some way to get from my start all the way through to my end. Now, I've given you a few options. Okay, as usual, I've given you a few misleading sort of examples of what to do and what not to do. Option A, 360.56 meters on a bearing of 213. If you're a little bit confused by the bearing number, that's okay. I'm going to dispel that later. So 500 meters on a bearing of 213.7. Okay, there it is, that bearing number. Or those same two options of displacement, except with a different reference to direction, and that was southwest. So options A, B, C, or D. Now, the problem is that a lot of people are just guessing. Grade 10s aren't used to being tested in this way. Now, you can't just shout out on the page, I think it's A, I think it's B, I think it's C, whatever might be the case. You guys have got to explain how you got your answer to get that calculator. Okay, absolutely vital. I'm telling Indy to ignore you. If you're just shouting out your answers, I want you guys to help each other figure out how to do this question. So if I think it's option A, this is why. If it's option B, this is why, so on and so forth. So let me just run you through the important info again. Okay, so we've got our map here. Each one of these city blocks is 100 meters by 100 meters. Each one of these roads in between is going to stretch in between these blocks. Now, I want you to ignore the width of the roads themselves. Not too important for this question. You've got to navigate from the start to the end somehow, and I've got to use the roads to do this. Now, in my traveling from the start to the end, I've got to figure out what the displacement is. Okay, well, the problem is I'm not entirely sure what these words mean. And if you were watching us last week, a lot of people got displacement and distance mixed up. So what we're going to do is we're going to spend a whole lesson making sure that you know the difference between distance and displacement. And that's the first clue to today's lesson. There is a very big difference between distance and displacement. Okay? So get yourselves from start to end, work around on that page, and try and figure out our challenge question. First correct answer, with an explanation, we'll get that calculator. All right, so let's get into our lesson today. Now let's start taking a look at what this word displacement actually means. So there it is in our nice blue writing. I'm just going to make sure that we highlight and make sure that we got all the important information in there. Now, just a little bit of revision from last week. I know that one is a vector and one is a scalar. I wonder if you can tell me if displacement is a vector or a scalar. Now, there's some very important information. Now, last week we took units and quantities to pieces, and I'm going to do the same thing for the next 30 seconds just to make sure that everyone understands what I'm saying. Well, the first thing that I've got is I've got a number, and that is a magnitude. A lot of people really get tripped up by this word magnitude because it's not something that I use in everyday life. So the word magnitude itself means how much do I have. The other thing which I notice is that there's a unit attached here. That unit tells me what I'm measuring. So this tells me that I'm measuring something to do with length. Now there's a third piece of information, and this is the giveaway. I've got a direction over here, and a direction is very important. A direction tells me that displacement is a vector. Now, I've put in a little bit of an explanation as to what displacement is. Displacement is the length from the starting to the ending point. Okay? Now, that should sound familiar because that's something inside the challenge question. Clue number 2, there it is. So from my starting to the ending point in a certain direction. Well, all of those options, A, B, C, or D, have got a direction attached. So that's not one of the ways that you can tell which one's incorrect. So starting to the ending point, I want you to start thinking about that very, very carefully. Now, when I take a closer look at displacement, it looks exactly like distance, but I've got this addition of the direction. That's what makes one of the major differences between displacement and direction. So moving onwards, what I'm going to be doing is I'm going to be showing you the differences on a map. Now, the map looks very confusing, and when I start taking a look at a map, I can start to see starting points and end points. I'm going to be drawing all over this map. Now, I've got a map here overhead of Centurion in the southern parts of Pretoria, and what I'm going to be doing is going to be writing all over our map. Now, the color which I'm going to be using is not the one on the map. I'm not going to be using orange or anything like that. I think green is nice and visible. So I've got a starting point over here. Starting point is Supersport Stadium, and I want to make my way through to the middle of Irene. So there is my ending point. Now, what I'm going to show you is the difference between distance and displacement. Now, if you were in a car, this would be your only option. So what I do is get in my car and I would start traveling various different ways. So that's exactly what I'm going to do, is I'm going to trace out a path. So I start at Supersport Stadium and I start traveling down my first road and I start making my way down there. And what I find is that I can only stick to the roads. So there we go. I've got this path and eventually I make this last turn and I arrive at my ending point. So what I've actually traced out is the route which I'm going to take. And any of you with those fancy phones with the maps on can actually do this for you. A GPS can do this as well. It can trace out the actual route which I take. Now, I'm pretty sure that you can notice that there's several turns along the way and that I traveled a great distance. What I've traced out here with this sort of pink or purple or magenta line is actually the distance traveled. This is the real world distance which I have now traveled. Now, this is not my displacement. What I'm going to do to figure out my displacement is I'm actually going to figure out what was the end result of my action. Now, to do that, what I'm going to be doing is I'm going to be using an arrow to point directly from the start to the end. Let me repeat that. I'm going to start from my starting point and I'm going to go to my end point. Displacement doesn't care how you got there. It's a path which is direct there. Now, you'll notice that I've actually got a ruler attached to here. Now, what I'm going to be doing with that is I'm going to be moving around on this map, and I'm going to be showing you the difference between the distance and the displacement. Now, if I'm just taking these direct paths and these individual turned paths on here, I can actually measure how far I've gone. So now, first thing which I'm going to do is I'm going to measure the distance on my map. Now, of course, this is not a real distance. You would have to scale this up to many kilometers. But what we're going to do is we're going to see if distance and displacement are the same. Now, you can do this with a ruler because these are mostly nice straight lines. So we can go and add these up. So at my starting point, I'm going to put my 0 on there. And I'm going to rotate my ruler around. And let's start measuring. So what I've done is I've started to move. I've moved around about 2 centimeters over there. Then I go over there, and I'm going to find out very quickly that I go a great distance further down there. So I'm adding to my distance. So that's 2, and that's 3.5 altogether. My distance is adding up quite quickly. So at the moment, I've got 5.5 centimeters. So now what I'm going to do is I'm going to put my 0 back at the next turn, and we're going to measure even more. So we're going to try and measure our distance there. Okay, I'm going to add another 1.5 to that. So now, all of a sudden, I've got from 2, I've added 3.5, so we're at 5.5. Now we're going to add another 1.5. Now I'm already at 7 centimeters on my map. And then the last leg is around about 2 centimeters, and that leaves me with a total distance of 9 centimeters. So I'm going to write this in just to show you the difference between them. So my distance on my map is 9 centimeters. Now let's go measure my displacement, and this is way, way easier. I don't have to take into account all those turns which I took. So let's pick up our ruler, and the way that you measure displacement is where I started from to where I ended up. So what I find is that my displacement is very often much, much shorter than my distance. Sometimes there's an expression in English that says, as the crow flies. So if you were a bird, could you fly this route? Absolutely. You don't have to stick to the roads. So what I'm saying over here is that my displacement on here is 6 centimeters. So let's write that in with a green pen so that you know what I'm talking about. And here is my displacement. So there's quite a big difference between displacement and distance. Okay, I believe you guys are struggling to see the green. So what I'm actually going to do is I'm going to make a little bit of space down here at the bottom and summarize it. So let's see what goes on when we compare the two. So my distance, let's actually catalog it as we go. My distance, I measured a total distance of 9 centimeters. Okay, my displacement, which I actually measured, and let's keep it in green because you guys know what the green is all about, because the green was the arrow directly from the beginning to the end. So there's my displacement, and my displacement I actually measured to be much, much shorter at 6 centimeters. Now, if I was to give this as my final answer in an exam, I would not get my marks. What I've got to do is I've got to give some sort of direction. Now, here's a bit of a problem. How do I give direction directly off a map? And I'm actually going to make a little bit of space in order to do that. So let's just grab our eraser. Let's get rid of all this excess writing on our map. I wish I could do this in real life to my map. And then what we're going to do is let's just move our ruler out of the way. And let's try and figure out how we could describe our displacement on my map. Now, this map is oriented so that I've got a north pointing directly upwards. I know that north is upwards on this map. The question is, how would I describe the green arrow? I'm going to show you exactly how to do that. Anytime you want some sort of reference, you can draw a north arrow directly through the point where you started. So let's do exactly that. I've drawn in a north line. So now that tells me where north is. I've got to now measure out where this is in relation to north. So now if I've got north, which is up there, I want to know how much this angle is from north. If you were watching last week, what you'll remember is that that is actually called the bearing. That's another clue for our challenge question. So if you're busy working with your challenge question, the degrees clockwise from north. So in other words, the same direction as my arrow is the bearing. Now the question is, how do I actually measure bearing? If I've drawn this on my diagram, how do I take the bearing? Now if you've got your protractor with you, and I want you to have your protractor with you, I'm going to be doing this with you. Let's just make our protractor slightly smaller. Let's move it over to our north line. Okay, so now we're going to measure this together. Okay, now you can see that this is not very useful as it is. What I've got to do is I've got to make sure that my 0 line is on the same line as north. So let's just make sure that that's nicely in line, and we're actually going to go and measure. Now don't worry if you can't see all the fine readings on my protractor. What I'm going to be doing is marking them out. So at the moment, I've got 0 degrees on the north line. What I'm going to do is I'm going to rotate it all the way around, and I'm going to find out what the reading is over here. So let's actually try to figure out what that reading might be. If I measure on my protractor, and you should be doing similar things at home when you draw these vectors, I'm actually going to find out that there is 120 degrees from north in a clockwise direction. That tells me that I've got a bearing of 120 degrees. So now when I give my answer over here, I can't leave my displacement over there. What I've got to do is I've got to work with some sort of direction. So I can add to this. I can say 6 centimeters on a bearing, and remember that bearing means clockwise from north, so a bearing of 120 degrees. Now, it's not always going to be that easy a number. Sometimes you've got to calculate, and sometimes you've got to work with slightly more complex numbers. Let's just go through this again, the difference between distance and displacement. Distance takes into account the entire path. Displacement goes directly from start and ends up at a finish line. It doesn't take into account that I had to turn all the way down there. And displacement is almost always shorter than your distance. But there's something else which is special about displacement. It's got a direction. Now, if you're watching last week, now you can use north, east, south, west if it's a map. The problem is what happens if you don't have the cardinal points, you don't have the compass points. We're going to show you how to work with that a little bit later on. Okay, so now if I was to write this green arrow, let's just make sure that this is correct. Let's actually move away our protractor. We're going to use that a little bit later. How would I write in this green arrow? I would say that that is 6 centimeters on a bearing of 120 degrees. Now, a lot of people are not that comfortable using bearing. That's okay. We're going to be working with it quite a few times. I hope that you saw that we could measure this directly off our map. We were quite lucky because the map was already facing north. Always make sure that you know where that is. All right. The last thing which I'm going to be doing with you before we take our first short ad break is I'm going to be giving you a few directions, and I'm going to be showing you how to work with these directions. I'm going to be showing you how to add up vectors. Okay, so what I'm going to be doing is I'm going to give you various directions just as you would to somebody inside a car, and I'm going to ask you to follow them and ask you what the final displacement is. I'm going to show you how to scale them up, how to draw them out, and how to work with these. So we've got our first direction. I'm told from my starting point to go 120 meters east. Now, most of you figured out that it's very difficult to measure out 20 meters, and it is actually a real pain in the butt to do this in classroom, because I've got 20 meters. I don't have 20 meters to measure this out. So what I've actually got to do is find a way to do this on my ruler, and that's a real challenge. So I've got to scale all of these down. I've got to work with my protractor. But what I think we should do is let you write these down. So 20 meters east, 10 meters south, 5 meters west, and I think you guys should work through. And I think we're going to take a short ad break. What do you think?
Let's give you a break, Phil. Hey, we should just make Phil work all day. Okay, guys, I see that you've got quite a few answers that are coming in on Facebook to the challenge question. Yolandi and Zon and others that have just placed, just the A, B, C, or D, guys, please let us know why you have chosen those answers, because if you show us why you've chosen the answers and you show the workings out, you could be winning this awesome Casio calculator. And we'll be going over that at the end of the show. Okay, let's take a break and we'll see you now.